a 500-ton machine made of metal, passengers, fuel, and cargo suspended in mid-air, flying thousands of miles at 35,000 feet, defying everything our instincts say about gravity. How is this even possible? Is it magic? Is it luck? No, it's pure science, driven by the laws of physics, brilliant engineering, and over a century of innovation. Let us decode the hidden genius behind flight from theory to takeoff. About the four fundamental forces of flight. Every airplane in flight obeys four fundamental forces, each constantly acting on it. Lift of flight that provides upward force, weight gravity that provides the downward pull, thrust that caused the forward motion, drag that provides the resisting force of air. When lift greater than weight, the airplane rises. When thrust greater than drag, the airplane accelerates. Without this precise balance, flight is impossible. It is like a tightrope walk between air and gravity. About lift, the force that holds up the sky. Now the real question is, how does a plane actually generate lift? The answer lies in the wing, specifically its shape. About the science of the wing. Airfoil, the cross-section of a wing, is called an airfoil. It's shaped with a curved top and a flatter bottom. When air flows over the wing, the air on top must travel a longer path and moves faster. The air underneath moves slower. According to Bernoulli's principle, when air is faster than pressure, is low. Conclusion of Bernoulli's principle: high pressure below the wings. Low pressure above the wing gets pushed upward, then lift is generated. But that's not the whole story. Newton's third law also plays important role for every action. There is an equal and opposite reaction. This is Newton's third law of motion. Third law of Newton is application of force. As the wing deflects air downward, the air pushes the wing upward. This is called DOWNWASH. So lift is not just a pressure difference, it is also momentum transfer. Bernoulli plus Newton is equal to realistic lift. Wings do not suck planes up, they redirect airflow and manipulate pressure to generate controlled elevation. Thrust, which is reason for flight. To fly, an aircraft must move forward fast. That is where thrust comes in. Jet engines of aeroplanes, a symphony of fire and force. Jet engines, turbofans work in 4 steps: intake, which suck in huge volumes of air; compression, which squeeze the air to high pressure; combustion, which mix air with fuel and ignite it; exhaust, which blast out hot gases at extreme speed. This ejection creates opposite forward motion. Thrust, as per Newton's third law. It is like standing on a skateboard and throwing a bowling ball backward as you shoot forward. Modern engines like those on a Boeing 777 can produce over 100,000 pounds of thrust per engine. Drag force, which is invisible enemy for aeroplanes, is the resistance created by air as the plane moves through it. There are 3 main types of drag: parasitic drag, that is caused by skin friction; induced drag, which is a byproduct of lift; wave drag, which moves an object at supersonic speeds. Engineers fight drag by making planes sleek and aerodynamic, using tapered shapes, smooth surfaces, and winglets to reduce vortex turbulence. Without drag control, the plane would waste fuel and lose speed. Balancing the sky when flight will be in equilibrium. Cruise flight. Lift is equal to weight, thrust is equal to drag. This is called equilibrium. The aircraft maintains altitude and speed, but during takeoff, lift is greater than weight and thrust is greater than drag. When a plane lands, then lift is smaller than weight and thrust is smaller than drag. The pilot or autopilot constantly adjusts the aircraft using elevators, rudders, and ailerons to manage pitch, yaw, and roll. Even a small change in air density, speed, or temperature requires precise corrections. From Wright brothers to hypersonic dreams. In 1903, the Wright brothers made the first powered flight, just 12 seconds long. Today, a Boeing 747 can stay in the air for 16+ hours, carrying 500+ people. Military aircraft like the SR-71 Blackbird fly at Mach 3+1 match is equal to speed of sound. NASA's X-59 will soon make supersonic flight silent. Flight is not just travel, it is a miracle of physics, a triumph of engineering, and a symbol of human genius. The sky is not limited, it is just the beginning. Next time you look up at a soaring jet, don't just see metal, see Bernoulli's airflow equations, Newton's third law in action. Precision, engines burning thousands of gallons of fuel with microsecond timing, a billion lines of code balancing everything in real time. Airplanes fly because we have decoded nature, harnessed invisible forces, and built machines that turn gravity into a game. And that is how humans learn to fly.